Hello students, my name is Alok Simwal and today's topic of discussion is anti-tubercular agents. In this lecture, I will discuss introduction, classification and mode of action of anti-tubercular agents. I will also discuss structure-activity relationship of Isoniazid. Tuberculosis is an infectious and communicable disease caused by Mycobacterium tuberculosis. In short form, this bacteria is known as MTB. Tuberculosis generally affects the lungs, but can also affect other parts of the body. Mycobacteria are intrinsically resistant to most of the antibiotics, which limits the number of drugs available for treatment. Drug resistance occurs when bacteria and other similar microorganisms change over time and no longer respond to treatment by medicines. The intrinsic resistance is due to several reasons, like mechanisms including a thick, waxy, hydrophobic cell envelope made by the mycobacterium and the presence of drug-degrading or modifying enzymes. Because mycobacteria grow more slowly than other bacteria, antibiotics that are most active against rapidly growing cells remains relatively ineffective. Mycobacteria cell wall is lipid-rich, and that is why it remains impermeable to many agents, including drugs used in the treatment. Mycobacteria grows inside the macrophages, which are specialized cells involved in the detection, phagocytosis and destruction of bacteria and other harmful organisms. Macrophages generally have poor drug penetration rate for most of the lipid-soluble antimicrobials, while for other antimicrobials it has intermediate intracellular penetration rate. The bacteria that cause tuberculosis can develop resistance to the antimicrobial drugs used to cure the disease. Multidrug resistant tuberculosis does not respond to at least isoniazid and rifampicin, the two most powerful anti-tuberculosis drugs. Anti-tuberculosis drugs. Anti-tuberculosis medications are agents used to treat tuberculosis, a disease caused by the bacteria Mycobacterium tuberculosis. It is a type of infectious disease that can affect the lungs and other organs. Tuberculosis disease treatment strategy include a combination of antibacterial medications for a period of 6 to 12 months depending on which drugs are used. The most common treatment for active tuberculosis is isoniazid in combination with 3 other drugs, rifampicin, pyrazinamide and ethambutol. Following combinations are used not only to overcome the obstacles in the treatment but also to prevent emergence of resistance during the course of therapy. Classification of anti-tuberculosis drugs include 2 main categories: synthetic anti-tubercular agents, which are used as first-line therapy, and anti-tubercular antibiotics used in second-line therapy. Drugs used in first-line therapy generally have high anti-tubercular efficacy as well as low toxicity. Drugs in this category includes isoniazid, thionamide, pyrazinamide, ethambutol, and aminosalicylic acid. Drugs used in second-line therapy generally have low anti-tubercular efficacy or high toxicity. Drugs in this category includes antibiotics such as rifampicin, rifabutin, cycloserine, and capreomycin. Next is mode of action of few important anti-tubercular drugs. Isoniazid is an antimycobacterial agent which is bactericidal for both extracellular and intracellular organisms. It is the primary drug for the treatment of tuberculosis. Isoniazid is a prodrug whose principal effect is to inhibit the synthesis of mycolic acids, thereby producing bactericidal effect. Mycolic acids are high molecular weight branched hydroxy fatty acids that constitute important components of the cell walls of mycobacteria. Various research studies indicate that isoniazid also interferes with mycobacterial metabolism of vitamin B6. Next is mode of action of ethionamide. Ethionamide exerts its bacteriostatic activity by virtue of inhibition of arabinosyl transferase, which is responsible for bacterial cell wall synthesis. Arabinosyl transferase is an enzyme that polymerizes arabinose into arabinin and then arabinogalactin. Arabinogalactin is a very important mycobacterial cell wall constituent. It is composed of highly branched polysaccharide, serves to connect peptidoglycan with the outer mycolic acid layer. Mode of action of rifampin. Rifampin is thought to inhibit bacterial DNA-dependent RNA polymerase. Transcription of genetic sequence in bacteria is mediated by DNA-dependent RNA polymerase. Rifampin binds to the polymerase subunit deep within the DNA or RNA channel, facilitating direct blocking of the elongation of RNA, leading to a suppression of RNA synthesis and cell death. Next is a structure-activity relationship of isoniazid. So before starting structure-activity relationship, it is important to know about the chemistry of isoniazid. Isoniazid is an isonicotinic acid derivative having molecular formula C6H7N3O. Structurally, it is a pyridine carbohydrazide obtained by formal condensation between pyridine 4-carboxylic acid and hydrazine. Basic skeleton of isoniazid is consist of pyridine ring system having a carbohydrazide side chain. Various studies suggest that the first nitrogen in hydrazine side chain of isoniazid should be unsubstituted, while the second nitrogen can be substituted with alkyl groups to get active compounds. Till date, numerous derivatives of isoniazid have been developed, but none of them have exhibited activity superior to that of the parent ring. Replacement of pyridine nucleus with other aromatic rings such as benzene, piperidine, thiazole ring diminish the anti-tubercular activity related to the parent isoniazid molecule. In another attempt, when isopropyl group is substituted at R2 position, the resultant was N2 isopropyl derivative, which was named as iproniazid. This drug, apart from anti-tubercular activity, was found to exhibit psychomotor stimulant activity. Following are the references of this topic. Thank you.